Okay, hello, we are group 69. Our members consist of myself, Julian, Taiki, and Jane. And our project for our distributed cloud web app is a news platform which has credibility ratings. So here's the sections we'll go through in this presentation. So we'll go through our background and motivation, followed by our project architecture and applied technologies, followed by our distributed database design, which uses Cassandra, our visualization, and our front-end user interface, and finally, we have our Spark programming. So our background and motivation. So the inspiration for our project is Elon Musk's Twitter post, which he asked users if they would like a media site which has a credibility rating. Majority of users said yes to this, and 88% saying this would be a good idea. Also, as Trump famously puts it, fake news is the enemy of the people. Architecture and applied technologies. So for our applied technologies, we use React for our front end, and we also use Jupyter for our interface to interact with the Spark cluster environment. And we also have for our backend, our API server uses Flask, which is written in Python, and of course our Spark. For our platform infrastructure, we have Google Cloud Platform to host all our nodes. We use a tool called Terraform to instantly create, delete, and manage all our infrastructure from compute engines, virtual private networks, firewalls, everything, and so on. We also use Docker to containerize our applications. So the only dependency each node needs is to have Docker installed. And all the other libraries and dependencies are installed inside of Docker. We use Nginx as our load balancer and static file server. And finally, we use Cassandra as the distributed database. So for our architecture, let's start off at the client side. So the client connects to the master node, which has a load balancer running Nginx, and that distributes traffic to the front end, which is our React.js, our backend API server, which runs our Python Flask, and also to our Jupyter Notebook, which uses PySpark. Our Jupyter Notebook in turn connects to our database to fetch data, and then sends jobs to our Spark master, which distributes them to Spark worker nodes. For our front-end, users will fetch the static resources, and they will send API requests to the Python Flask API server, which will in turn fetch results from our Cassandra database. And then it will do some data processing and return the results. All of our resources are built using Docker images, and they are stored in our container registry. So our deployment model is pretty easy, pretty straightforward. We use Terraform. We use Terraform init, plan, apply, and destroy to connect to our Google Cloud platform using a service account. And then we can plan the infrastructure, the configurations. We can apply that, and that will build everything automatically. And we can also destroy the entire stack all in those in that one command. So we have a total of 4 commands that does everything. So we create 3 nodes, a master, a slave, and 2 slaves. And our master, we run our API server along with our client server, which is distributed, and also our Jupyter Notebook, all of which is load balanced by our Nginx load balancer. In our slave, we also run, in our slave nodes, we run the Cassandra cluster duplicates, and we also run the Spark worker nodes. Moving on to our distributed database design. In our distributed database, we try to use unique IDs to identify all most of our tables. This way it makes partitioning data into different nodes really easy and querying data a lot faster. We also have some duplicated data because Cassandra is a NoSQL database. So for example, we have author name, which refers also to user's name. And we also have rating count and rating sum, which is also the same as score and ratings table. This is so that querying data, you only need to query from one table, rather than two, so it makes read operations a lot easier and faster. Another thing to note is we use two tables for user and user credentials. We use user credentials for logins, so anonymous users should not be able to see user IDs. So we can use email as the primary key to quickly query data. Moving on to the user interface and visualization by Taiki.
Yes, let's start the user interface and the visualization explanation. So there are three main contents in this application: articles, authors, dashboard. So in articles, also this is a home page. Looks like this page. And this is a specific article page. User can see the title and the other article data. And this page for creating article. This page is this page shows specific author information. So author name and articles what they wrote in this application. So this is a dashboard pages. In dashboard pages, there are main two sections: global section, global page, and personal page. And this this window shows personal page of dashboard. So let's start UI demonstration. So in this demonstration, I will log in, create article, view article, and rating specific on article and show dashboard, see dashboard global pages and personal pages. So let's do the login. So this is the login form pages. User should input their email address. And password. If user login successfully, user can see the create article button on header. So let's make an article. So input title, add tags, and body. So let's upload it. So user can, after make a new article, user can see the recent article in the recent article pages. Let's see the article. So in this specific article page, user can see the title, tag, and also name and bodies, also the average rate of this article. And after user login successfully, user can add the rate in each article. Let's say, okay, this article is 3. And let's back to my article and see user can see the average rate of this article 3. Yep. Then let's start see dashboard. So this is the dashboard pages, and the user can see the global page. Any user can see the global page even if user they don't log in. So in this page, a user can see the most popular tags and the most popular authors in this application. So let's move the personal page. So in this pages, users should log in, and this page shows what this account read in this application. For example, in this my most viewed tags, user read these tags articles, and in the my most viewed authors, it shows the authors who the user account read in this application. See this user reads the test user's article and JSON's articles and also his self articles.
All right, next up we'll talk about Spark programming. And so we can see here we are using Spark with Python, and it's mainly for admin to do exploratory data analysis. So we have two main data sources. One is the data in our database, and one is from our log file. And the data in our database is the data generated by users on the application level. And as you can see here, we can calculate the author's overall ratings, and we could also calculate the rating before specified date. And also we could generate the number of articles generated every day to monitor the traffic and users' activities. As you can see on the right, we're using different technologies for this, and the PySpark SQL and the regular expressions are used to retrieve the information, and PySpark SQL is used for both, and regular expressions is mainly used for the log file because the data stored like on the log file is in strings, so we are recognizing the pattern and retrieving different data types. And the Python pandas, matplot library, Python Seaborn are used for visualization. And the second is our log file. As you can see here, we are running a few analyses for our log file. I will jump straight into demonstration for detailed explanation. So let's start with log file. The first part of this is just setting up and cleaning the data. And as you can see here, we have our, these are the pattern that we use to retrieve data from log files. And then, so here comes our first analysis. That's we are running some stats on the content size. That's the bytes of the package delivered over our network. And the second analysis, we run the analysis on HTTP status code, and we can see that the 200 status has the most hit, which is good. And then we are putting it on a bar chart for better visualization. And also we display the top 20 frequent endpoints that are visited by our users, and also top 10 error endpoints that could be used for future, to update the part of our code. And that's for endpoints as well. And also run analysis on 404 not found responses on our website, and that's about it. And we move on to the analysis we run on the data in our database. Okay, and yep, so the first analysis we run is we could calculate the rating of each author. And then second is we specify a date, and then that's the rating of that author prior to that date. And the third is that we are generating the number of article posted by date. So yeah, that's about it. Thank you.